So today I am discussing about free body diagram. So free body diagram is just it's a FBD. FBD stands for free body diagram. Okay. So free body diagram. Free body diagram is just I can say the number of forces, number of forces acting, number of forces acting on a body. Okay, so or by the body also. So total number of forces, how many forces are acting on the body? Okay, so just what to representation about this, a diagrammatical representation of number of forces acting on a system or number of forces acting on the system or by the system. So this can be represented by what? Free body diagram. Okay, so just I'm taking about this is first. So for example one I'm taking, there is on a horizontal surface, here is the horizontal surface. Okay, a block is taken this, yes, its mass is m. Okay, the mass of this one is what? M. Yes, so free body diagram means how many forces, this is what? Contact surface. Here is what you say, it's a contact surface. Here in between these two, what forces are acting? And next one, let it be, I'm considering this is what? Some applied forces, capital letter F. Okay, applied force is capital letter F, and there will be some frictional force. Just to imagine that this is what? It's a friction, right? And the coefficient of friction is given, it's a mu. Means if applied force is unbalanced force is in forward direction, frictional force is in what direction? Backward direction. Okay, it's what? It is in backward direction. To find its acceleration, to find its acceleration and to find the different parameters. So first of free body diagram we need to take about it. So first one, step one, we need to do this one. What is the step one? Separate the systems. Separate the systems means what? Separate the bodies. So what are the bodies? This is what? M. Okay, next one is what? Here is the ground, right? Yes. So between these two, normal reaction, normal force acted by M on the ground is N. So by the ground on this one is what you say? It's a N only. Yes. Next one, frictional force on this surface is what you say? It's a F. Yes, frictional force. And next one after this, so this is what? Applied force, capital letter F. Yes. So when the acceleration is in forward direction, we can write it's a equation. Yes. So I can, this is what I can go for just this is what? One isolated system is taken, an individual system is taken. Yes. So for the individual system, here is for upward forces at the balancing condition means okay. Otherwise, so this is N is, so its weight is what? It's a mg. N is equals to what you talk on this? It's a m into g. It's a weight. Okay. Otherwise, when it is in equilibrium, okay, at equilibrium position means what? At a is equals to what? 0. For example, body is accelerating. Accelerating means what? We need to write the equation. So free body diagram, its mass is m. This is what? Applied force. This is what? Frictional force. Unbalanced force is in what direction? So in the forward direction. Forward direction, its acceleration is what? A. So then net force is equals to F net is equals to capital F minus small letter f. F net means what? MA. According to Newton's second law, we can apply on this. So is the first case like this is the for the free body case, means number of forces acting on the system, and to find its acceleration and to know about this one. So different parameters when it is moving in forward direction, or if it is at the equilibrium position also we can find it. I'm taking one more. For example, just I'm using as this is horizontal surface is taken. Yes, two blocks are considered now. Okay, there are two blocks are considered. Okay, so first one, upper block is what I have taken as what? It's a m1. Next one is what? It's a m2. This is what? Horizontal surface. He may ask us what is the normal reaction between m2 and ground. what is the normal reaction or what is the force between M1 and M2? Okay, anyone he may ask us. Okay, so just what, according to draw the free body diagram, separate the bodies. First one separated. Yes, next one, it's what, M2. Okay, it's what, M2. This is what, M2. Next one is what, it's a M1. Is M1, M2 and ground. Let it be M1 is acting, so its weight is what, M1g. Its weight is what, M2g. Correct, it's a M2g. Now, so this normal force acted by the ground on M2 is, let it be N2, by M2 on this ground is what, it's a N2 only. Next, so acted by this M2 on M1 is what, N1. So this must be what again, N1 only. So what do you want to write on this? So first you take it as isolated system. For which system you want to consider as this? Just I want to talk about this is the upper one, right? Now, so what is there? N1 is equals to M1g. So if you speak about this lower one, okay, lower one is what, this is what, M2 for understanding I am writing this. Okay, it's a M2. And N1 is what, this part is acting downwards, it's a N1. Okay, N2 is what, it's a like this upward, and its weight is what, M2g. Weight is what, M2g. So then N2 is equals to, for this system, N2 is equals to, what is this? It's a M2g plus N1. M2g plus N1. Okay, so here N2 is equals to what, M2g plus N1 is what, M1g. So N2 is equals to what, you say, M1 plus M2 times of what, g. G stands for acceleration due to gravity. Yes, so my here to find for 1 2 3 like any bodies are mentioned. So just for the problem solving, like a trick, if you maintain as this is what trick. Here are that how many bodies you have. There are two bodies. First one is what, it's a M2. Next one is what, it's a M1. 10 coins are placed one above one. 20 coins are placed one above one. Whatever the situation is given, first I need to know about this normal reaction. Yes, sir, between these two, where you want to find it? Yes, so where you want to find it? So for example, I want to find the normal reaction between M1 and M2. Place your hand here, like, place your hand means what? This is what, horizontal line. Above your hand, how many masses do you have? It's a M1. N1 is equals to M1g over. Place your hand here. For example, between these two, some normal reaction you want to find. What is this? It's a N2. So above this one, how many masses you have? So there are two masses. N2 is equals to M1 plus M2 into what? It's a G is a case. So free body diagram for the single body system, or for like a two bodies placed one above one, like we can represent. So let us take one more example for this. For this is what? Horizontal surface. How many masses? There are three masses. Okay, like this. It's what? For example, 30 kg. Okay, this is 20 kg. This is what? 10 kg. He would ask us, what is the normal force between ground and 30 kg? Let it be, here is what? It's a N1. Okay, this is N1. This is what? N2. This is what? N3. Like we can write it as. Okay, so this I want to know about this N1. N1 means what? Above this your hand, how many masses do you have? Three masses. Three masses means what? 30 plus 20 plus 10 into G. Okay, so this N1 is equals to, so it's a 60G is my first answer. So if you go for this, if you want to find about this N2, N2 means N2 above this N2. How many masses do you have? There are two masses, 20 and 10. So it's what? 20 plus 10 into what it's a g. N2 is equals to, we can write 30 g. Okay, it's 30 g. So similarly for n3, n3 means what? Above 1. Okay, this above this. What is there? How many there are? So last one, it's a 10 g, like we can mention it. So is the method to find about this free body diagram of any number of masses are mentioned, like any system is given, like we can go on this. Okay, so this, based on this, the blocks are in contact. One block is connected by a string. The string is passing over pulley. Whatever the situation is given, you should get it clarity on what? Free body diagram. Okay, so just I'm giving one situation. The situation is what? Here, there the two masses are taken. I'm considering about two masses. Two masses. One is, it's a m. Next one is what? It's a 2m. Two masses are there. They are placed on a horizontal surface. Okay, so let it be, it is a frictionless. It's a smooth one. Smooth one means mu value is what? It's a 0. Okay, so next one, if I apply a force on m, for example, if I apply a force on m, this, apply a force. Okay, what force is this? Let it be, it's a 3 Newton force is acting on this. On which one? Smaller mass. Okay, so this, my question is about what is acceleration of the system. So do you think both of these to have the same acceleration? Yes. So total system is moving as a single body. Acceleration is what? Same. And so what is the normal reaction between these two? So what is the normal reaction between these two? Contact force, otherwise the force between m and 2m. Any terminology he may ask us. So what is n? So between the bodies is my question. Okay, so just you can solve about individually free body diagram. For m, next one for 2m, acceleration is what? In the forward direction. This is in the direction of what? Applied force. Okay, so you I'm giving a basic idea on this. How should I take as this? First one, m1 is taken. It's a m. This is what? 3 Newton force. Normal reaction is what? It's a n. Its acceleration is what? In forward direction. Right. And next one is about heavier one. Its mass is what? 2m. So this is what? Normal reaction n. Are there any other forces? No. So give the direction of acceleration, this. Okay, okay, so now write the equation for the free body diagram. How should I write the equation of motion? Sorry, not equation of motion, it's an equation in the direction of acceleration. In what direction body is moving? In the forward direction. Okay, net force is equals to F net is equals to, which is more, 3 minus n. F net means what? Newton's second law. It's what? MA is equals to 3 minus n is my first case. Okay, it's a 3 minus n. My here net force is equals to, we can write as net force is equals to, how many forces are acting? It's a n. F net means what? MA. MA means what? 2 MA is equals to what? n. This is my second condition. Okay, so that from the equations 1 and 2, if I move on this, it's what? From the equations 1 and 2, if I apply, this is what? MA is equals to 3 minus, what is the n? 2 MA. Okay, so from this 2 MA transposes from here to here, it becomes as what? 3 MA. 3 MA is equals to 3. Okay, 3 cancel. Is it? Okay, so this is what? 3 minus 2 MA become as plus, and 2 MA plus MA means what? 3 MA. 3 cancel. MA is equals to 1. A is equals to what? 1 by m. A is equals to 1 by m. So what is the normal? For example, this n I want to find it. First one, my answer I got it as what? A is equals to 1 by m meter per second square. Okay, so next one, if you move in which one? this relation from the second one, if I talk about n is equals to 2m into what a, n is equals to 2m a. Okay, n is equals to 2m into a. What is the a? 1 by m. 1 by m. Mm cancel. What is the answer? 2. So n is equals to 2 Newton. Okay, it's the force is measured in what? It's in a Newton is the case. In the further this I got it as from the free body diagram. We need to follow a trick on this. For the problem solving, we need to follow a trick. So the trick is what? So what trick I need to follow for this? Just you see, for very important, it's a trick. The trick is what? What force is acting on the system? It's a 3 Newton force. F is equals to ma m1 plus m2 into what? A. F is equals, F is what? 3. M1 is what? M. M2 is what? 2M into what? A. It's a 3 is equals to 3ma. So 3 cancel. A is equals to what? 1 by m. Thus we got it. A is equals to what you say? It's what? 1 by m. Okay. So next one, sir, I want to know about what? N. N means what? From where you are acting the force this side. Which is the free end? This is what? Free end. What forces are acting on the free end? N is equals to what? N is equals to 2ma. 2m into a is what? It's a 1 by m. So mm cancel. What is this? It's a 2. It's a 2. Is a way. So first one, it's a traditional one. This method, if you know, you can do this. If you without knowing this one, this is what our original method. Okay. So like directly while solving the number of problems, you will get clarity on this, how to solve and easy manners like. So I applied the trick for this. Next, I'm talking about what is the tension. What is tension? Okay, just what is tension? Yes, what is the tension? Tension is internal force in the string. Tension doesn't change position of any body. It acts always away from the mass. So tension is what? It's a T. Yes. So this I can say an internal force. Internal force. Internal force in a string. Inside the string is called what? Tension. This is what? Tension or tensional force. It's a tensional force. Okay. So now the second one is about tension. Tension T always acts away from mass of a body. Mass of body. Yes. And the most important thing, tension when you're talking, this tension is what? In the string I said. What is the string? What is the string? String may be thread. String may be wire. It may be rope. Okay, like anyone we can talk on this. So for the string, when you're talking about this string, for these all the cases, here for the ideal one, it's what? Ideal. Ideal string means what? Ideal string. It means what? It's a massless string. What do you mean by massless string? What does it mean by massless string? Do you think it doesn't have any mass? No. It has the mass, but the mass of the string is, as compared with the mass of the body, is negligible. That is what? Massless string. Now when you speak about the massless string, otherwise ideal string, tension at every point constant. Tension at every point constant. Okay. the tension is constant. But tension at every point is constant. Okay, fine. This is what massless string. If I take about mass of the body, for example, it's a 90 kg. Mass of the body is 90 kg. Okay, so then the string is connected or the suspended by means of a rope. Okay, the mass is what? It's a like just what 90 grams, like very small as compared with this. Okay, so this ideal string means what? When you're talking about the ideal string, the tension constant at every point. It always acts away from mass of the body. It always acts away from mass of the body. Yes. But if the mass of the string is considered, if mass of string is considered, considered means what? Mass is there, means tension is not same. Tension is not constant. Its tension is not constant at every point. Tension changes from point to point. This is about the tension or tensional force. Okay, just let me give a simple example for this. So take a body. This is the fixed position. A string is connected. Its mass is what? M. The mass of the string is what? It's a M. This is what? It's a fixed position. It's a fixed one. Is okay? Now let me talk about. So again we are coming to the free body diagram only. But before this, what type of forces are acting? This is a string which is ideal. Its mass, this is what? mg. It's a weight. Tension always should act away from mass of the body. Is the system is accelerating? No. Acceleration is equals to 0. You write the equation. The equation is what? F net force is equals to what? mg minus t. F net means what? ma. Ma is equals to mg minus t. Acceleration is what? 0. Then t is equals to what? You write. It's a mg. It's a mg. Sir, this is what? Suspended. If it is suspended, so the weight is acting on this. You may raise a question. The question is what? If the block is placed on the horizontal surface, how does the tension act on the system, on the bodies? Okay. So this is what the best example for the tension. If I go for this, a block is placed on, so this is what? On the horizontal surface. Is horizontal surface. Okay. On this horizontal surface, two masses I am connecting this. Its mass is m1. Another mass is what? m2. Its mass is m1 and m2. Okay. So let it be some extra. This is what connected by the string. Some external force is acted. This is what external force. Obviously you say acceleration is what? In the direction, rightwards, in the direction of applied force. Okay. So then my question is about, I want to draw its free body diagram. How should I? Yes, let us see this free body diagram. Obviously M1, when you're talking about M1, tension is what? Away. How many strings do you have? Only one string. One tension at every point which is same. So this is what? Tension T. Yes. It's what? When you're talking about the mass. So I want to go for the free body diagram. Yes. This. Its mass is M1. Normal reaction. Okay. Directly I'm writing upwards. Its weight is what? M1G. Tension is what? T. So tension, it acts what you say? It's a like this is what? So do different places there now. You take about N1. Sir, I want to write about the free body diagram for M2. Yes, M2. Sir, applied force is capital letter F. And normal reaction upward. N1 na? N2. Its weight is what? M2G. Acceleration is what? In a forward direction. For your kind information, When it is there is no friction is not considered. When it is moving in forward direction, means what, this vertical components gets cancelled, only this is there, and these things, the tension, sorry, here tension is there, tension is here. Okay, so just I represented free body diagram. So about the strings are connected, so for the bodies. Next, like this is second example. So how can I approach for the problem solving? Sir, one string, okay, this is what a string is, this is a fixed position. It's a third example I am moving for this. Okay, so here this it's a mass m is suspended, and next one, it's what, if I move this, this is what you say, it's a mass m1 next to mass m2. Let it be, just let it be this. String is ideal, that you remember, string is ideal. Draw the free body diagram. Draw the free body diagram. Yes, draw the free body diagram. For the drawing free body diagram, this is what, tension. Here is what, tension. Its mass is m. This also t. Its weight is what, mg. See, I am dividing into isolated systems. Sir, this will be what? How many strings do you have? There are two. Can I write it about T1? Due to this one, it's a T1. Due to this one, it's what, it's a T2. Due to this one is what, it's a T2. Away from mass of the body. Yes. So, if I represent this, string is connected, tension T2, again mass, it's a M1, tension T2, tension it's a T1, and next one again, it's what, M2, its tension is T1, its weight is what, M2G, its weight is what, M1G. This is free body diagram. Sir, which one you want to discuss? I want to discuss about this, or this one, or this one. Anyone you can talk on this is the way for the drawing about free body diagrams. Okay. So, like we can discuss on about it. I'm taking one question. The question is what? Is these are the models which we discussed now. The question I'm taking as this. Here is the question. Okay. So I'm taking about, there is horizontal surface. Okay. Here some mass is m. The horizontal surface, first one is mass m. Next one is what? Here another mass. It's a, for example, m is what I'm taking 10 kg. It's a 10 kg. This is 30 kg. Let it be. It's a 30 kg. Yes, just you can go for. Okay, it's a M1 10 kg and 30 kg connected by the ideal string. The force applied here F, which is 80 Newton. The applied force is what? 80 Newton. The question is, what is acceleration? What is the tension in the string? What is acceleration? What is tension in the string? Yes. Let us move on the concept. So first you go for free body diagram. Here is 10. This applied force is in forward direction. This acceleration also in forward direction. Is okay. So it's what? First I'm taking about free body diagram of this 10 kg. Tension is away from this. Tension is away from this. This is what it's a T. Are there any other forces in the direction of motion? No. I'm not talking vertical direction. I'm talking about in the direction of motion. In the direction of motion only T. Okay. So next I'm going for this. It's a 30 kg. It's a 10 kg. Okay, so we'll move on this. It's what this is what F is equals to what 80 Newton, and tension is what it's a T. Acceleration is in forward, acceleration is in forward. You can solve the equation. The equation is what? F net. F net means what? MEA. MEA means what? 10A. 10A is equals to T is my first equation. F net is equals to how many forces are acting? It's a T. Okay? MEA 10A is equals to T. And this way, F net means what? Net force 30A is equals to 80 minus T. 30A is equals to 80 minus T means what? It's a 10A. Bring here. 40A is equals to 80. A is equals to what? 80 by 40. It's a 1 jar, it's a 2 jar. What is the answer? 2 meter per second square. It's a 2 meter per second square. Yes, sir. What? First one, this is what? 2 meter per second square. Sir, I want to know about the tension. What is the tension on this? This, na? Okay. So from this case, T is equals to what? 10 into A, correct? T is equals to 10A. T is equals to 10 into, what is A? A is what it said 2. This is 20 Newton. My answers are these two. What trick we need to follow for the problem solving? Say, this what the total force F is equals to what? MA. MA means what? M1 plus M2 times of A. What is F? 80. M1 is what? 10 plus 30 times of A. I'm changing this color for different. Okay. This 80 is equals to 40A, then A is equals to 2 meter per second square, isn't it? Yes, sir. Whatever we got it. So from the free end, you choose always the free end. This is the free end. How many forces are acting on the free end? It's a T. T is equals to what? MA. M is what? 10A. T is equals to 10A. T is equals to 10A. T is equals to 10 into A is what? 2. It's a 20 Newton. T is equals to 20 Newton. Is a way, so for the problem solving based on what it's a Newton like. Okay. So in the tension, always acting away from mass of the body. So from all the cases we understand that first the major source is what? Free body diagram. Divide into the isolated systems. Present how many forces are acting on this. Identify how many forces are acting in the direction of motion. Then apply the equation. Is okay? Thank you.